So good morning, everyone. Thank you for having me in Vilnius. It's so nice to be here. It's just a beautiful place, and I'm excited to be here and talk to you all about offline first mobile applications. First, let's take care of a little bit of business here, and we'll talk about slido.com. So if there are any questions at the end, be sure to use this hashtag. So let's jump right in. Why offline first mobile? Well, hold on a second. Let me download the rest of my presentation here. Hold, please. Does anybody have the Wi-Fi password? Oh wait, we're at a conference. Wi-Fi sucks, right? This is not going to work. Shit, what am I going to do here? I'm kidding. It's a joke. All right. So my point was made. I appreciate that. Thank you. We couldn't have planned. I'm just going to have to give him like 20 euros here for making my point for me. Okay, the first piece here is that making users wait is bad. So every time you see that spinner, users get frustrated, right? So every time you're trying to do something on your phone, because phones are very personal, right? Like this is something that has a lot of information about you, about your friends, about your personal life, about things that you do, like your bank account and all that kind of stuff. So users want to have control of that, right? And so when you make them wait, they get frustrated and angry, and then they have a bad reaction to the app that you've created. And that's not good for your business or your app. So you don't want to make your users wait. Well, the problem with that is networks are not reliable. So, if you're in a place and you get, 1 bar of service, you don't really have service. So how do we deal with that? You make your apps offline first. So we're going to talk about what offline means, and there's actually more to it than you might think before we talk about how you make your app offline first. So first off, airplane mode. This is the simplest one. So this is anytime you turn on this little airplane mode, that actually physically turns off the radios in your device, right? So now your cellular connection doesn't have any power, and your Wi-Fi connection doesn't have any power. And asterisk, you can turn Wi-Fi on in airplane mode on planes now, but generally what that means is the power is off to the device. So that means there is no communication going in and out. And this is an important distinction because in iOS specifically, when you make a network connection and get a response, you get a different answer when the radio is shut off. You actually get an error and you don't actually get a response. So it's a different condition for the developer to handle, and this is why you as QA people need to know the difference. The next situation is when you've got a really, really, really poor connection, right? So you've got this 1 bar and it kind of flicks on and off, and you're like, well, I should be able to get some data here, and it just spins and spins and spins, and you're like, come on, I need my data, and it's just not happening, right? So this is a special case where timeouts come into consideration, right? Because the developer has the ability to set a timeout for how long a network connection takes, or how long you're going to wait for a network connection to come back with an answer. So if you have it set to like 60 seconds, a user's going to be standing there going, well, any day now, I'd like to have my data. Come on. But if it's set to something reasonable like 5 seconds, well, at that point, if you don't get your response in 5 seconds, it's not going to work in 60 seconds, right? So maybe you want to think about shorter expiration times on that. Now, the last one here is kind of a special case, and not a lot of people are aware of it or how to handle it properly. So this is called a captive portal. Has anybody ever had this happen to them before? So you go to a hotel and you're like, yeah, I want to use the Wi-Fi. And then you've got your Wi-Fi, it looks like it's connected, and you're like, okay, google.com, and I can't connect to okay, what's going on? And then eventually this thing pops up, and it's like, oh, hey, welcome to our Wi-Fi. Would you like to sign on and accept all our terms and give us your email so we can email you every day? That's a captive portal. And that's a special case because you'll actually have an active Wi-Fi connection. Everything in the system thinks you've got a good connection, so it looks like everything should be working. But you actually don't have a connection until you've cleared this portal. All right, so now let's talk about offline first mobile and what that means. So there's a few different considerations here. The first one is you always, oh God, I can't see my own notes. You always want to handle all, or at least most, of your user stories offline. Because there's definitely going to be user stories that you just can't do offline. You can't log in offline. It doesn't work. But you want to consider all the cases in your application that matter to your users and see if you can handle those offline. You want to show all the available data that you have quickly. You want to be very responsive to the user, so you want to have that come up on the screen. You don't want to have spinners. You don't want to have blocked user interface or prevent the user from being able to control the app at any given time. So anything that you've got, you want to be able to have the user see quickly. You want to be responsive when you're loading remote data. And what I mean by this is, let's say something's taking a long time, right? And I don't know if you've seen these web apps, right, where it'll gray out your entire screen and then it's spinning and you're like, all right, I want to see my stuff. This is taking too long. I want to go do something else. And you try to get away from it and you're stuck. And the only way you can do it is to kill the app and start over. That's not a good situation for your user. So you want to be responsive to the user's desires. And if they want to cancel something or just stop trying to load something that's taking too long, let them. And then you want to report your network status or your last sync time. So you want to let the user know whether they should expect to see data. So if you're in one of these situations like the captive portal where you actually have a great signal but you can't connect, tell the user, hey, I can't connect to the server, and here are some things you might want to try to help you figure it out. And then last but not least, when the network becomes available, and this is a key point for a good offline app, automatically sync up your data. Right? Don't make the user do anything. So if there's something that you can do in your app, consider what can I do automatically in the app when I know my network status has changed to sync up my data. And that can be pulling new data the user expects to see or sending up data that the user has created while they're offline. Okay, that wasn't last but not least. So note, this is not easy. It actually can be very difficult depending on the architecture that you choose and how you approach it. But it's definitely worth it in the long run. All right, so let's look at typical architectures here. So a typical network connected app is going to have, services and some data and, all kinds of stuff in the cloud. And this is a really generic architecture diagram, but it sort of gets the point across, right? And then your user application on your mobile device will typically use a REST API to call up and say, hey, I'd like to get this data that you've got on the servers over there, and I'd like to pull it down and see it on my device. And then I might create some data on my device, and I might send it up via REST, right? So that's a pretty typical architecture for a lot of network-connected apps that have data that needs to go back and forth. So the process is you'll make these API calls, and you'll receive lists of objects that come down, or maybe an individual object with some detail. You'll ingest or process that object so that it's something the app can work with and do things with, and then you'll just update the UI with those processed objects so that the user can see them. Pretty easy, pretty straightforward. So the pros of that are it's very simple, this is mature, people understand how to do it, this has worked for years, and it works really well if you've got good network connectivity, right? So you might not even know the architecture of the app. If you've got a good network, it'll just seem instantaneous and feel really great to the user. That's great. Now the cons are, once you start getting poor network conditions, the app starts to stutter, it starts to not respond very well, and then you get a poor network experience when that starts to happen, or a poor user experience when that starts to happen. The worst is when you're on a captive portal and it's like the user sees the Wi-Fi and they say, well, I've got 4 bars of Wi-Fi, I've got a great Wi-Fi connection, why can't I connect to anything? And they don't know why. And I don't know if anybody's had this experience where you go into somewhere where you've connected to a captive portal before, and you reconnect to it, but the portal doesn't come up and say, hey, please join our network. So you're stuck and you don't know why. And this happens in a lot of different places, especially with people that are going in and out of hotels and stuff like that. So this is something you want to pay attention to and solve for your user if you can. And the trick here for you QA people is to get on a captive portal and get that portal to the portal window to appear. You need to make an HTTP connection, not an HTTPS connection. Because you'll make HTTPS connections because that's, you do good architecture and it's all secure and all that kind of stuff, but you'll never trigger your captive portal. So pay attention to that. And then using this architecture, you may not be able to get anything done offline. And so a lot of different web apps that are built into native apps, native apps that are just wrapped around a web app, they actually can't do anything offline. So the app is completely useless when you're offline. And that's not the best thing for your user. So let's talk about the architecture of an offline app, an offline first mobile app. And I've actually built this, whoops, sorry about that. I've actually built this using Google Firebase, most recently AWS, Couchbase, and then using REST APIs. So I've built the same architecture with a lot of different underlying technologies. But the same architecture applies in all these cases. So you're always going to have your services, kind of off doing their thing. But inside your app, the key point here is that the app's user interface is never talking directly to the services or the network. Okay, and this is generally good architecture anyway. But the key here is that you talk to the local storage first, and you find what you've got, right? Display that to the user. Now the sync service will independently work with your services that are network provided or remote services, and then they'll update the local storage and then say, hey, I've got new data. At which point the app user interface can respond to the new data, and then you can either just refresh what you've got on the screen, or you can do some real nice animations and show the changes and how stuff appears in your lists or your individual data. So this architecture ends up being a really, really good way to approach the problem. Now let's talk about that a little bit in detail. So how does this architecture work? So first, the app UI will query the local storage and then display that. And that's always a lot faster than a remote call is going to be. So that's how you get your responsiveness. The next thing is the sync and network will refresh changes from the remote server. This can happen independently of the user interface, and actually that's a really good way to approach it. But you can also have the user interface drive those changes. So if the user's like, hey, I want to refresh, you can allow that change too. So then, the sync and network service can then notify the local storage and say, hey, I've got new data. And this is what we just talked about, is once that new data is available, then the user interface can update and be responsive to those changes once they appear. And then all right. So the pros of this approach is this is much, much more responsive to the user. So if you're talking to the local data storage, your user interface is going to update much quickly. You're going to have a lot fewer spinners. You may have some user interface to say, yeah, I am checking for new data, but you can still interact with that data since you're talking to your local storage. Okay. There's another nice benefit for the developers in the crowd is this gives you a really nice clear separation of concern, right? Your user interface should only be talking to your local data and then local objects, and not driving network stuff directly from your view controllers. So if you follow a good architecture here, you just get easier to deal with code. And then the last piece here is this works really, really well offline. It works with bad network conditions, and then it works with good network connectivity. So the user should never know that their network just went down, their cell signal is bouncing up and down, they've got a really good signal now, they've got a really bad signal over here. The app should function the same no matter what the network conditions are. Now the cons of this are, this is obviously a more complex process, right? There's a few more details that you need to sort out. There's definitely some edge cases here that you need to deal with. And then you might require some extra UI to illuminate the user as to what the network status is or what the app is doing in terms of syncing data. And this can be more challenging to implement and get right. All right, so then you're asking, okay, well, that all sounds great, but I've got this network-dependent social app, right? And that's all I do is pull fresh data. So what do you do about that? Well, the first piece here is if you are pulling data frequently, you wouldn't want to fail gracefully, right? So you want to have a nice, instead of spinning and spinning and spinning and doing something like that, you want to figure out, you can look at your network response time, your average network response time under a good network condition, and you can figure out a request should never take more than 2 seconds on a good network, right? And then you can extrapolate that on something very slow and say the absolute worst case should be 10 seconds. So don't set your timeout to 60, right? Make it 10, make it 8, make it 5, and that's really good for your user. Okay, don't make the user wait long. And then always have something to show, right? So if you've got data that you looked at last time, have that right there, have it be instantaneous. And then don't make the user wait long to see something. And then again, let the users have access to what they've created. Oops. Well, I just got back. Oh my gosh, now we're lost. Help! All right. Sorry, I just blew right past this point. All right, so let users access the content they created. This is really important. So if I've got a nice social app and I'm like trying to create posts and stuff like this, I get frustrated with Twitter or whatever else when I'm like, I just want to post something and I may not be in the best network conditions, right? And if I can't post it right now and it's like, sorry, not connected, you can't post, I'm never going to remember to do this later, and it was a really great, funny thing that I was going to post. Let the user save that offline, and then let that sync up as soon as the network is available next time, right? And then let the user see what they created in the normal flow of the app, right? So that way is a really good user experience, and then let the user know, okay, well, this content's created, but it hasn't synced yet, so nobody else should expect to see it, right? Now this might not be as easy as it sounds, but that's a really good user experience. And then, again, let the users create remote content offline. So like I said, with Twitter or whatever, that can be really frustrating when you can't post something and you're offline. So giving the users the ability to do that regardless of the network conditions is really a great feature. All right, so now we've talked about offline and offline first mobile. So hopefully all that is clear. Now I've got a lot of testing professionals in the room, so I'm going to talk about not necessarily how to do the testing. I've got a few points of advice on that, but you guys are expert testers. You know how to do all this probably much better than I do. But I'm just going to give you some of the considerations that occur when you're doing offline first. And we're going to talk about a few of those different positions, or a few different parts of the app that you need to take into consideration. So the first one's going to be authentication. Then we're going to talk about downstream data syncing, so just pulling data from the server to display on the device. And then we're going to talk about how user-generated data syncing has considerations. We're going to spend a few minutes on image loading, because that's kind of a special case, and there's some nice ways to deal with that. And then we're going to talk about UI indications in your app. All right, so first let's talk about authentication. All right, so you open your app, you want to see Rory. Rory's a T-Rex. My daughter made Rory. She has a sticker app for this, so I had to promise that I would show it here. So you open your app, you want to see Rory, right? Well, the problem is you're offline. You logged in before, but now that you're offline, you can't log in, and it gives you this this dialog for your username and password, and you're like, I just want to get in and see Rory. And then you sign in, and it says, sorry, no Rory for you. You're offline. Ah, good luck with that. Rory's not happy. This is bad. So what you want to do is make sure that you've got an authentication method that handles offline, right? So you need to be able to log in, track users, and all this kind of stuff that you want to do with your application. But make sure that authentication method handles mobile and handles offline situations, right? So you've got a token or whatever the mechanism is that you can check locally on the device and say, have I logged in recently? Can I still act as though I'm logged in and do stuff locally and then sync up later? So this is the ideal solution for offline first mobile when you have an authentication situation in your app. When you're testing this, make sure that you go through all these different scenarios, right? You want to make sure that you're testing where I've never signed in before, right? Do a new account. And make sure that app works correctly when you're online and when you're offline, and you get a nice error message that doesn't just say, sorry, failure message, ER 3001, invalid something or another. You just want to say, sorry, I'm offline, I can't connect right now, but I'll save this information that you typed in for the next time that you try to create your new account. Wouldn't that be nice? Do the same for not logged in. You should just give a nice error message when you're offline. And then your logged out state going to logged in, do those both offline and online, and make sure that works the way that you expect. A lot of times it won't, and you'll be like, And you can actually, I've seen cases where my developers have made mistakes and got the app in a completely wedged state where it's stuck between logged in and logged out, and that's bad. And then you want to go through the logging in, from logging in to logging out. And if you have any considerations when you log out, like, for example, if you're tracking devices that are in your service, and you need to make a call when you log out, you need to take that into consideration. Make sure that works the way you expect as well. All right. Next up is downstream data syncing. So I'm going to talk about how mechanically how this works, typically with an offline first app. So a lot of times you'll have on the server side, the data that you want is going to be broken down into adds, changes, and deletes, right? And then your API call is going to say, give me everything since maybe a timestamp or maybe a hash. And so that's just a marker that says, give me all these changes that have happened since the last time that I synced up, okay? And so those changes will come across, and then the app will receive those changes, apply them to the local storage. And this is the most efficient way to do this kind of thing, rather than having to download the entire set of data every time that you need it, right? The adds, changes, and deletes can be very, very quick. All right, so what that typically looks like on the server is you'll have this list of changes, and those can be marked with either a date stamp or a hash, right? So that's what the table will look like. And as you go back through those hashes, you can get more data and apply those changes to your local storage. So as a tester, why do you care? Well, there's a bunch of things you need to think about here, which is if I've given the user a starting point of data, I need to make sure that that starting point is accurate and then updates correctly, right? So you want to make sure that you're, because a lot of times when you do updates to the app, you're going to change your starting point of data, and you might ship a new starting point of data. And so there'll be considerations of, do I use that new starting point the next time I open the app? Am I replacing that starting point of data in the app? Or am I going with what the user already had? So those are things as testers you need to understand and make sure you test properly. And then the next piece is going to be, from my starting point, am I testing those updates to the included data correctly, right? So I've got my app, I've updated it, got my new starting point of data, and now I expect some changes to happen. So make sure those come in properly and show up the way that you expect them. All right, so now that you've installed it, everything's working, make sure you're testing your adds, your changes, and your deletes. I had a terrible case with a client where they could process the adds and the changes, but they couldn't tell us the deletes. So we had to make a query and get the list of all the IDs in the entire database. And then we had to figure out what we had locally and then delete the ones that weren't there anymore. So that was a pain for the developers. But as testers, you want to make sure that whatever process the developers are having to suffer through to make sure the syncing works is actually doing the right stuff, and you're not deleting stuff that you shouldn't be deleting. And then you definitely want to test your upgrade versions with changes, not only for the included data that we just talked about, but for schema changes. So if you're adding new pieces of information to your object model, right? So if you're adding new fields, or you're taking away fields, or changing the names of fields, you want to make sure those changes are very thoroughly tested, because previously those could cause crashes in mobile apps if they don't deal with them properly. All right, so that's downstream data syncing concerns. Now let's talk about user-generated data syncing. All right, so this is going to be fairly similar, where you're going to have adds, changes, and deletes on the local device, and the user's creating new content, taking pictures, adding comments, all that kind of stuff, and then all that stuff is going to need to get synced back up to the server. Now this can get a little bit complex, and we're going to talk about this. So let's say I'm Instagram. I've got a piece of data that's represented. I'm taking this nice picture of a mountain with a stream. So that's a piece of data. That's an ad. Well, that piece of data, the image, may also have some associated data to describe what it is, right? So the metadata about this image. So it might have a name, and it might have a unique identifier, and it might have some other pieces of information that my system needs to be able to display it properly. So now I've got a dependency between those two pieces of information, because I'm probably not sending them up in the same API request. Well, I'd like to be able to like my own picture, because it's a really cool picture, right? So now I've got another dependency. And then I kind of want to make a comment about how great my pic is, right? So I've got one more dependency. Now, how do I handle all those dependencies when I'm shipping them up? And one thing I want to point out here too is it's good to understand as testers where the unique identifiers for all this get created, right? In some cases, the unique identifier for the image or the image data or the favorite might get created locally, right? So that might just be a UDID that gets created locally. Or that unique ID might be created on the server. And what happens then is if you're doing all this dependency, I need to upload the first piece of data that gets the unique ID, and then I need to update my temporary ID to all of my dependent data and make sure that it gets applied to the right objects. So as testers, this is your job to figure that all out and make sure that it works the way that it should. So let's talk through that in a little bit more detail. So when you're testing upline user-created data that's been created offline, you just want to make sure the basic method works first, right? So you're online, you just create some stuff, and all that should just flow properly, right? Then make sure all the dependencies work. So I've created an image, I can now favorite it, I can add a comment to it, all that works, it shows up in the right place, that's all good. Now get into the failures and retries, right? So let's say I created that whole graph of dependent objects, have it fail in the middle, have the image upload properly, have the metadata fail, go offline, online, and then try to have it sync back up again and make sure that it recovers properly from an error. This is where I've spent days banging my head on the desk trying to get this to work properly, and this is where you'll get really hard to debug errors or failures. So this is a really good place to test, is if you can force failures in the middle of resolving that dependent object graph that's been created offline. You can really help out your developers by finding problems. So you'll want to, when you're testing this kind of stuff, you're going to want to look for like duplications or other sort of unexpected artifacts, right? Where stuff gets attached to the wrong thing or just doesn't get attached to anything and disappears. And you're like, I swear I added a comment to that. Where did it go? And then make sure it's still queued up if it did fail. All right. So then you want to check visibility offline, pre-sync and post-sync. So here's what you're doing is when you create some new content, and if you've been showing it to the user already, so let's say you've got a list of posts, and when the user created something new, it showed up in the list offline, which is great, right? That way the user knows they got some confirmation that their content is going to show up somewhere. When you do your sync now, make sure it stays in the same place and doesn't move somewhere else, right? Or get lost, because that can be very frustrating for the users. So you'll want to make sure that the sorting still works and that there isn't any weirdness in the refresh, like stuff flashing or anything like that, or that that you don't have a nice animation to animate or show the user that something's been refreshed after it's been synced up with the server. All right. Now let's talk about image loading. So the typical image loading process is, you've got a bunch of images sitting on a web server. You've got an API endpoint. You're just like, okay, send me the mountain picture, and now I display it. Easy, right? Well, that doesn't work at all when you're offline, because now I can't connect to my server, so what do? Well, the easy answer is you have a cache, a local cache, and iOS and Android both support this, and I know web stuff can do this too. So you create this cache, and this gives you the method of having a place locally where you can just pull down your images. And loading these images from the cache tends to be a lot faster than loading them remotely. So this is always a good thing to do, just generally speaking. If you're doing image loading and you don't want to do anything else offline, you can do just this piece and get a nice, it'll make your app feel a lot faster if you're looking at the same images more than once. So some techniques you can use for this, if you're leveraging the HTTP standard for remote loading, eTag. People use eTag in here? I'm not seeing any hands. Nobody uses eTag? Okay, so eTag is an HTTP standard that web servers support, and it's basically just a hash that says, here's an identifier for my resource that's sitting on my server. So for an image, it'll just do it's a 60, I forget how long it is, maybe a 32-bit hash that says it's a stamp or an identifier for that image. So if I replace that image, so if I create a new version of my mountain picture, the hash will change. So that way I know if I need to reload something or not. And I can also specify expiration, in my standard HTTP stuff. So if I'm on iOS, I can use a URL cache or an NSURL cache, and on Android, I can use my HTTP response cache. And if I'm using these caches with the eTag, what will happen is when I first try to load an image, I'll say, do I have it in the cache? Nope, don't have it. I'll download it. Once I have it, I'll be able to check that E tag, and then HTTP does all this for me. I don't need to write any code to do this. And then say, hey, let's check that E tag. Does that match? And it does a head request, so not even a get, right? It does a head request and says, does this E tag match? If it does, it doesn't download. It just returns from what the cache has. And then if it is different, then it will go ahead and complete the get request, give you your new image. So using that approach and just all the built-in stuff there, you can actually get a lot of benefit from the HTTP standard for your image loading. All right, so let's talk about some of the considerations you need to test for this. Obviously you need to do the basic remote loading for your connected situation, right? So just making sure you're loading images. This should be plain vanilla, should just work, right? Then you want to test, go offline, load your images from the cache. Sometimes this might not work. If your cache isn't configured correctly, it'll just stop working. You want to check expired images and make sure that they don't load from the cache. And then you might want to check your changed images, right? So you want to make sure you change images for the same endpoint and make sure those reload the way that you expect them to. And then last, you want to make sure that you check unchanged images to make sure that they aren't generating network traffic. So this is something you'll want to use Wireshark or Charles or something like that, so you can watch the network traffic from the device and make sure that it's doing the right thing. Because this is an important consideration. If you've got a very image-heavy app, you don't want to kill the user's battery by trying to do a whole bunch of network requests, when you don't really need to. All right, so let's talk about UI indications a little bit. So you always want to show your connection status when it matters to the user. So if the user is expecting a case where they might want to see some new data, or they might want to be uploading data, or they might want to see where their content is, did it upload yet? Should I be telling my friends to go look for this post I just made? So let the user know about that when it matters. Especially stuff like, when you're going to a screen that always shows new content, let the user know what's going on there. And then maybe if you've got a pull to refresh, show the user that. And then especially, I've hit this point a bunch of times, but when the user creates new data and expects to upload, having a good way for the user to understand what has happened to their content is really important. Don't make the user wait for data to load. I'll say that one more time. And then show your progress as accurately as possible. One of the best examples that I think is out there is if you're using the iOS App Store app, you'll notice the progress has got it's a circle, right? And then it actually does the progress in the circle. So instead of just being a spinner where I don't know how long it's going to take, the circle gives me a really good indication of how long it's going to take. And since I can see it moving, I know whether it's going or not, and what's going to matter there. And then show that last sync time if it matters. All right, so some considerations that you want to take are, be sure to test those connection states and make sure that they show up correctly in your UI. And then the big one is testing the transitions between states. So going offline to online, online to offline. The slow one is the easy one, right? The hard one, I call it the BART test. So if anybody's been to San Francisco and ridden on the BART, it's a really loud and bumpy and smelly experience. But it goes through in and out a lot of tunnels and stations, right? And so your network connection goes on, off, on, off, on, off. And that can be really stressful for the app trying to do the syncing. So make sure that your app supports all that. So let's talk about a couple of techniques here. Definitely you want to try testing on multiple, so do Wi-Fi by itself, turn off cellular, make sure Wi-Fi works. Do cellular by itself, turn off Wi-Fi, make sure that works. Offline, test all the different situations that we talked about, or all the different scenarios that we talked about. So the airplane mode, Wi-Fi on, not connected, and then your cellular on, but you don't have a good signal. And then for testing a poor connection, there's kind of a number of different ways you can do this. You can use iOS Network Link Conditioner, Android, either in the emulator, you can use that. There's a setting to control that, or you can use a third-party app. You can use something like Charles, Wireshark, that sort of thing to make your network condition go down. And if all else fails, you can stick your phone in a coffee can under your desk in a basement or like in a microwave or something like that. All right, and then you can test the captive portal. This is always a pain because your timeout is so long, right? So if I go to a hotel, I do it, and then it's good for the next day. So I'm like, well, how do I test that again? So you can use like a gateway address. You can turn that off. Set an incorrect gateway address in your router to like just funnel your traffic the wrong way. You can use parental controls for this, or you can use something like Charles with a null route to sort of simulate what that's going to be like. All right. So that's what I've got for you today. I'm on Twitter here at JW Keeley. You can ask me questions anytime. Happy to help. Thank you to all the organizers and everybody, the staff here, for doing such a great job. This is a really fun conference. Now let's do some questions.